and we'll be recording, so don't.
Let's go.
Okay, so here I have drawn a triangle, right? And some of you may already know this, but if I add these three things together, so I measured each one of these angles. Notice if I drag here, that those angles all change, right? So that is the measure of each one of those angles. So then if I go to number, I think I could go to calculate, and I could add those three angles together. That ABC plus this one, okay, plus this one, okay, and I hit OK. I get 180 degrees, which most of you know already, okay? And isn't that cool with that sketch pad? So now notice that if I drag this around, those angles change, but does the measure of the sum of those angles change? No. Now there's a way that you can prove, there's a way that you can prove that this relationship is true, and which we'll do later on, maybe not today, but so now I've conjectured, I've used inductive reasoning. Okay, I've measured a bunch of triangles and say, hey, they always add up to 180. Now I want to try to prove that. So now I'm going to try to use deductive reasoning to show why that is true. So one way I can do that is by clicking this and then clicking this and go construct parallel lines. All right, and notice what do you know has to be true about this angle here and this angle here? They have to be the same because those are called what's? Do you remember? Alternate interior angles. Okay. What's got to be true about this angle here and this angle here? They're the same. Because if you have parallel lines, which you do,
What makes a square?
if you have parallel lines, stop. Sometimes it goes crazy here. Just can't get a hold of itself. Okay. If I have parallel lines, then those alternate interior angles are congruent. So this is congruent to this, this is congruent to this, this is congruent to this, and this angle here is congruent to itself, right? Now what's true about these three angles right there? What do they add up to?
180.
180. So if this one is equal to this one, and this one is equal to this one, and this one is both in this picture and it's in the triangle picture, what can you say about this plus this plus this?
180.
They add up to 180 as well. Do you understand the way that would work? So it's kind of like we're proving why the sum of the angles, because we know about alternate interior angles, we've accepted that to be true. And then we've known about these, those are true. And this angle is both in this picture and in the triangle picture. So that's why the sum of the angles of a triangle add up to 180. Okay? So now you could do homework based on that. So I'm not going to do too much other than to say they give you two angles. Say this angle is 70 degrees and this angle is 50 degrees. What does this angle up here have to be? 60 degrees. Okay? So you have some homework problems based on that? Yes, sir.
How did we get out today, do you know?
Okay, no, I don't know. Anyway.
You get out at 12:50.
Definitely?
Yeah, 12:50.
Can we
I thought it
continue
was
with the
12:45.
math now, please? Okay. If we know that this is 3x, and this is 4x, and this is 2x, could I find all of these angles?
Yep.
Yes.
Okay. How would I do that?
4x plus 3x plus 2x.
Exactly. 4x plus,
Lies below.
so anyway,
If you posted that.
so anyway, if I did have an isosceles triangle, I don't want to do that. Let's just make an isosceles triangle using this thing. Where's that? I think this makes isosceles triangle. There's an isosceles triangle. Let's do it right there. Let's move it up. I don't know why it's moving up. There's an isosceles triangle. Let's stretch it a little bit. There's an isosceles triangle. So isosceles means this is congruent to this, okay? And anyone want to make a conjecture about these angles on an isosceles triangle? Or maybe you already know that. They're congruent. And you could prove that pretty easily by doing, once we learn about triangle congruences and stuff like that. So these are called the base angles. Base angles. So that's your second conjecture. And about today. This is called the vertex angle. Vertex angle in an isosceles triangle, and this is called the base. And these, I think they call the legs, but I'm not sure. So if this angle is up here is 50 degrees, okay, what do these angles have to be? How would I figure that out?
Well, they have to equal 180, so you would minus 50 degrees.
Exactly. 180 minus 50, and then what would I do to that number?
Divide by 2.
Divide by 2, so I get 130, sorry. 130 divided by 2, which gives me 65 apiece, okay? So that's the base angles. So you should have, I forget what conjecture is. I'll give you a copy of the conjectures tomorrow. But the first one says that the base angles of an isosceles triangle are congruent. And then we have a converse of that. A lot of you guys have trouble with writing the converse. So who could tell me kind of what the converse would look like? What if I switch the if part and the then part around?
If the base angles of an isosceles triangle.
If the base angles, so the converse, here's one conjecture, here's the converse is true too. If the base angles of a triangle, are congruent, then what's got to be true about that triangle? It is isosceles. Okay, so that's all isosceles. Please, I always have trouble spelling. So then let's do one more example, and then we'll kind of be done. And you can, how do I make it? I'm going to make it look more interesting. Maybe I could take it and I could turn it. Where's a turner? Do I have a turner over here? Does this turn it? What turns it? Turn. There. Can I rotate it? There. Here. Ooh. I'm going to stretch it. Stretch it. That's not how I want to stretch it. I want to stretch it. Oh well. Well, let's just say this is how it is. So say I were to call this 2x. No, let's not do that. Let's call this 10x. Now let's call this over here 5x minus, let's make it really complicated, 5x minus 10. I don't know if this is going to work or not. And say I tell you this, okay? Could you figure out what this angle is over here? What does this angle have to be? 5x minus 10. So you would have something like 2 times 5x minus 10 plus 10x equals how much? 180, right? And so then you could get 10x minus 20 plus 10x equals 180. 20x equals how much? 200, don't freak out on me, mobile board. X equals 10. Okay, so this angle is how many degrees? 100 degrees. And this angle is, hey, that's a pretty good problem I made up, isn't it? Do both of those add up to 180? Yeah, and that's pretty much all there is to it. Okay, so that's 2 sections that I just taught you. Okay, so that the problems that you work on now for the next 15 minutes, no, we don't get out in 3 minutes, John. We get out to tell you, I have this I have this figured out.
Oh, we're on the
Monday.
Yeah, but we have an hour or two.
Don't you tell me, I'm a professional educator. Okay. I don't know what time we get out. Okay, so I think we get out at 1 I'll figure it out, okay?
I think we
All
can
right.
have
I'll figure it out.
Wait, your clock's 11.